Well, let's talk about the slope of a secant line and the slope of a tangent line because they're related to each other. A secant line, let's say I have a point right here. This point is C. If I go up to the graph, oh, that's a bad place to put C. Let me put it somewhere where it's a little bit there. That's better. That point right there, that point is C comma f of C. Okay? So this point, if you follow it over to the y-coordinate, that's f of C right there, or the y-axis. Okay? A secant line, what I would do, let me take a bunch of little lines right here. What I would do for a secant line is I would take all these different points right here, that point right there, and I would make a secant line with those 2 points. That's a secant line. The slope of that secant line, let's say that this point right here is D. This point D right here, if I want to find the slope of that secant line, it would be f of D minus f of C, that's the rise, over the run, D minus C. And that would be the slope of this line right here. It's rise over run. Okay? Then what I do is I take another point and I go a little bit closer. Let's call it E. And I go up to the line right there and I go over. That's f of E. And then I take the tangent line and I take the slope of that tangent. Here's the tangent line right there. And now the slope of that the slope of that secant line is going to be a little bit closer to the slope of the tangent line, which is really what we're after with these things. So then I would take another point a little bit closer. Right here, I'm coming closer, and I put that point right there on the graph, and then I draw that tangent line in, or the secant line in, and that secant line is going to be even a little bit closer to what eventually is the slope of the tangent line. And the tangent line, if I can erase all those things, let me just draw it in black. The tangent line is if I have this point right here, that tangent line is going to be the line that just barely grazes off of that point, and the slope of that tangent line is really what I'm after. So here's a formula that you've seen. The slope of the tangent line equals the limit as x goes to c of f of f of x minus f of c all over x minus c. That's the formula that you've seen. And think about what this is saying. The slope of the tangent line as what's x minus c? As x gets closer to c, what is x minus c getting closer and closer to? As x gets closer and closer to c, so here's my x. As this gets closer and closer and closer to c, what's x minus c? What's this distance? X minus c is a distance between x and c. What's that distance getting closer and closer to?
The tangent.
Nope, it's getting closer and closer to 0. That's what this is saying. The limit as x goes to c of f of x minus f of c over x minus c. X minus c is the distance between x and c. So as x is getting closer to c, what's the distance between them getting closer and closer to?
0.
It's getting closer to 0. That's what we're doing. We're starting here. We have these different tangent lines, or secant lines, and we're getting closer. We're getting those lines closer and closer and closer, and that's what the slope of the tangent line is. It's the limit of all of the slopes of all those secant lines as those points get closer to each other on the x-axis. That's the concept behind that formula that you've seen. So that's just, hopefully that helps you understand what these formulas are really after. This is just a slope formula. It's rise over run, but that rise and run, this value down here is getting closer to 0. The other one that you've seen says this: the limit as h goes to 0, right? As h goes to 0 of f of x plus h minus f of x all over h. Well, what's h now? It's the denominator. That's the same thing. It's saying really the same thing. The height, or that distance between these two things, is getting closer and closer to 0. It's the same. It's really the same formula, just in kind of two different ways to say the formula. And the idea is, again, we've got some point on our graph over here, and we're trying to get this point right here, x. We're trying to get here's f of x right here. There's f of x, and we're taking small little values h, and we're adding it to that, so that we're really close, but it's getting closer and closer and closer to 0. So this was h, and now, I'm sorry, the distance right here is h. That distance is h. And h is getting closer and closer to 0, which means f of x plus h is getting closer and closer and closer to f of x. Theoretically, is what's happening, and so that's the slope of the tangent line. Same way as was, again, a different way of saying it. Same question, same counter.